So in this video, we'll be discussing homeostasis in bony tissues. So how, the methods and the ways that we go about maintaining the bone. And we'll dig in a little deeper, as I promised earlier, into the bone functions. Not a whole lot deeper, but a little bit. So we'll start by talking about remodeling. So living bone is constantly being remodeled. And, just like people remodel houses and buildings, bones also get remodeled. So where there is damage to the bone, through daily use, osteoclasts can move in and they use their enzymes to dissolve the protein fibers and the acids they secrete to dissolve the bony matrix. And that releases the materials that are being broken down back into the bloodstream. Osteoblasts and the osteocytes that are already found in the bone matrix will then use those materials to strengthen and enlarge the bone or to repair the portion of the bone that has been damaged. And in this way, we are constantly replacing the bone material that we have in our bodies. Now, remodeling doesn't occur, at the same speed in every location in the body. Some areas, those that receive the greatest stress, are going to be replaced more often. For instance, the spongy bone there at the proximal epiphysis of the femur, that can be replaced 2 or even 3 times a year, while the diaphysis of the same bone is going to be relatively untouched and may not see complete replacement, or the recycling and remodeling, but over a 5-year period. So, depending on how stressed an area is and how much damage the bone receives, that really determines how quickly bone may be remodeled. Okay, so what are some other factors then that also play into how bone is maintained, how it develops? So let's look first at nutrition. Vitamins play a major role. Remember, I think we've talked a little bit about what vitamins are, but vitamins are cofactors to enzymes. So they are materials that enzymes require in order to function properly. And vitamin D is one of the primary vitamins involved, or that plays a role in bone health and normal bone development. And the reason vitamin D is so important is because it's required for proper absorption of calcium at the small intestine. And lack of vitamin D, so a deficiency in vitamin D in the diet, causes a condition known as rickets in children. And I've got an x-ray here of a child who has experienced rickets. And in adults, we refer to this as osteomalacia. Both of these conditions, what you see are poorly calcified, softened, and as a result, deformed bones. And so you can see in this child, the femur and the tibia are both misshapen because of the poorly calcified bones. So as the bones are being used, they bend and continue to develop with that bend in them. Vitamin A is also required for the activity of osteoblasts and osteoclasts, and a lack of vitamin A results in slower bone development, so slowed bone growth. Vitamin C is important primarily because it's a cofactor in the processes to building collagen fibers, so those collagenous protein fibers that are found within the bony matrix that provide strength to the matrix. It requires vitamin C in order to be made. And so the lack of vitamin C the result is slender and fragile bones, so bones that are brittle rather than being strong and hard. Last of all, exposure to sunlight is important as well, because this is how we begin the process of activating the compound that will become vitamin D. And so exposure to sunlight on the skin converts a cholesterol compound that is produced by the digestive tract and then carried in the blood. And it converts this cholesterol compound into an inactive form of vitamin D. And then later on, both the liver and the kidney are going to be involved in activating that vitamin D so that it can actually be involved in the processes of absorbing calcium at the small intestine. All right, so nutrition plays a role, but hormones also play a role in bone development. And so hormone secretions that are involved in the development of bone include growth hormone. And I'm going to give you a tip here. One of the things that we'll be doing in this second semester course, at the very end of the second semester course, is taking a look at the endocrine system. And so we'll be looking at the effects of the different hormones. And so I want to encourage you now to maybe start by making some note cards on each of the hormones that we discuss as we talk about them in the chapters on each of the body systems. And so growth hormone has an abbreviation, capital G, capital H there, is the abbreviation for growth hormone. And it's secreted by a gland in the brain called the anterior pituitary gland. The pituitary gland has an anterior and a posterior section with different responsibilities. The anterior pituitary gland produces like 9 different hormones, and growth hormone is one of them. And the effect that we see of growth hormone on bone development is that it really stimulates division of those cartilage cells as the cartilage model is developing. And then later, especially during the growth spurt that we associate with adolescence, we'll see cartilage cells dividing rapidly at that epiphyseal plate. And so there at the epiphysis of the bone, that rapid cartilage growth for a time will exceed the rate of the bone ossification of those cartilage areas. And so that leads to that growth spurt that we associate with long legs and longer arms that happens in early adolescence. A lack of growth hormone in children produces a condition called pituitary dwarfism. With pituitary dwarfism, individuals are, the relative body proportions are appropriate, and so it's just a miniature version of a full-size person. An excess of growth hormone in children and then on into adulthood produces a condition known as pituitary gigantism, where a person could be very, very tall, and so there are records of people who exceed 8 feet in height as a result of pituitary gigantism. And then in adults, if this pituitary secretion of growth hormone to the excess occurs after the closure of the epiphysis, that growth plate. So after growth plate closure is finished, then it produces a condition known as acromegaly, where even though the long bones can't continue growing, some other parts of the body will. And so the hands, the feet, the jaw are all affected. And so it really changes body proportions, especially in the face and with the hands. So that's growth hormone, one of the influences. The thyroid hormone also has a great effect on body or bone growth. So thyroxine is one of 2 thyroid hormones that are secreted by the thyroid gland. Thyroid gland is located in the cervical region, on sort of laying over the trachea, the windpipe there at the front of the throat. And thyroxine is important because release of thyroxine by the thyroid is part of what stimulates the release of growth hormone by the anterior pituitary gland. And as a result of thyroxine also has activity directly at the cells that are involved in bone development. So we see an increase in osteoblast activity and an increase in the speed of epiphyseal closure when the growth plate on long bones finally becomes entirely bony. Another hormone is parathyroid hormone. This is secreted by the parathyroid glands. There are 4 parathyroid glands, and they're found on the posterior surface of the thyroid gland. So if you were to flip over the thyroid gland, that's where you would find these 4 small dots of different kind of glandular tissue that produces this parathyroid hormone. Parathyroid hormone is really important because it is the primary regulator of blood calcium levels. So if the body is low on calcium, so if there's a deficit of calcium in the blood, this stimulates the activity of osteoclasts. So the osteoclasts will move in, begin breaking down bone, and as a result, they're going to release blood calcium or calcium into the blood. So first we see a release of calcium into blood, and then it also will step in and inhibit the activity of osteoblasts. So it'll slow bone building. So it increases bone breakdown and inhibits bone building because it slows down the osteoblasts. And so between these two effects, blood calcium then increases. And levels of calcium are important in the blood because having appropriate levels is because muscle contractions, we'll see in the next chapter, that muscle contractions rely on calcium. And then we move on into the nervous system. We'll see that nervous impulse transmission also requires blood calcium, a sufficient supply of blood calcium. Other hormone secretions include calcitonin. Calcitonin is released by the thyroid gland, and it's secreted in response to low blood calcium levels. I'm sorry, I apologize, let me try that again. It's secreted here, I'll write it just to make sure, in response to high blood calcium levels. So if blood calcium increases, then we see secretion of calcitonin, and what that does then is slows down the activity of osteoclasts. So with calcitonin in the body, then osteoclasts are slowed, and if they slow down their activities, then that allows the osteoblasts to kind of get in front of it, and they'll use more of the calcium out of the blood, and we're not going to be adding to the calcium in the blood. And so we see blood calcium levels dropping as a response to calcitonin. And then last of all, the last hormonal influence that we want to talk about that relates to bone development and bone maintenance are the sex hormones, estrogen for women and testosterone for men. So estrogen is secreted by the ovaries, testosterone is secreted by the testes. There's no abbreviation for estrogen or testosterone. But these are the primary promoters of that adolescent growth spurt that causes that brings on the secondary sexual characteristics that are seen in the skeleton. So we're talking about, for females, widening of the pelvis. For males, the pelvis remains more narrow. For males, we see broadening of the shoulders, especially. And with females, the shoulders remain relatively narrow. And the other characteristics that are related to the skeleton and sex. So both estrogen and testosterone stimulate the ossification of of those cartilage, that cartilage material there at the epiphyseal plate, and stimulate then epiphyseal closure. And it turns out that estrogen has a stronger effect in stimulating this greater, more rapid ossification. And so women make their way to epiphyseal closure more quickly than men. So let's think for a second. If for men that growth plate remains open until 18, maybe as late as 21 years of age, but in general, on average, between 18 and 20 years of age. Whereas for women, we see closure about somewhere between the ages of 13 and 16. So, and most generally around 14 and 15. So, if that epiphyseal growth plate, if it closes at a younger age, then that's going to result in shorter stature. And so that's what we see. Men, because their growth plates remain open for a little bit longer time, they reach greater heights than women do who get to growth plate closure at a younger age. All right, so what are some other characteristics that will cause or produce some of the differences that we see in, or the maintenance that affect the maintenance of our bones? Stress on the bones certainly will cause a big difference in how strong the bones are, how well calcified they are, and even the thickness and size of the bones. Because as we do exercise or as we use our skeletal system, the little micro fractures is how I think of them. They occur. We do damage. We mess with the collagenous fibers. We mess with the calcium phosphate salts, and little tiny breaks and tears and rips occur in the bone. And so the osteoclasts move in and they clean up those areas, and then the new osteoblasts will move in, or the osteocytes around that damaged area will become more active and go and fill in and reinforce that area. And so over time, use of the skeletal system helps to promote the greater strength of the bones. And so for both men and women, the younger, the sooner after puberty this kind of work begins, the stronger the bones are, so that especially, and this is a bigger problem in women, that as they get to menopause and estrogen production drops off very rapidly, then the osteoblasts aren't getting the same kind of kick in the pants that they were with estrogen. And now it turns out the osteoclasts are relatively unaffected by estrogen. So with the loss of estrogen, those osteoclasts, they are still busy working, breaking down the bone, but the osteoblasts aren't getting that impulse to go. And so women postmenopausally can have a real problem with bone density especially. So there's big concerns about that and the development of osteoporosis. So the more work that women can do while they are producing estrogen to use their bones, strengthen do load-bearing activities, and do other things that are going to stimulate these microfractures, that is actually doing you good and helping to create greater bone density prior to menopause, so that it takes longer for osteoporosis effects to show up. Hopefully longer than even in the 80s, women can still have a relatively stable and strong skeletal structure. So lack of any physical stress, on the other hand, allows the activity of the osteoclasts to remain high, while the activity of osteoblasts is reduced, and this results in thinner. I wrote thicker. I meant thinner. Let's change that right there. So in thinner and weaker bones. So astronauts who head off to the space station and stay there for 4 to 6 months or longer even, I know there was at least one who was there for a year and a half, they can experience some very significant loss of bone mass. And people who have their limbs immobilized because they're in a cast or are on bed rest will also lose significant amounts of bone density. So using the bones definitely helps to keep them strong and ensure that you're protected against the fragility in the bones. All right, so I promised you that we would finish up this section by talking about functions of the bone. So support, this a huge function of the skeletal system, and so it provides, the bones provide a hard framework to support and to anchor all the soft tissues and provide attachment sites for tendons of skeletal muscle and for the ligaments that hold bones together. So, for instance, the pelvis and the legs support the trunk of the body. The rib cage is there supporting the muscles of the thoracic wall. Protection for the internal organs is also a very important function. The fused cranial bones protect the brain. The vertebra enclose the spinal cord, and the ribs are there protecting the thoracic organs, the lungs and the heart, and even portions of the liver. Movement is critical function for the skeletal system. Again, the skeletal muscles attached to the bones and using, by way of tendons, and they use the bones as levers to both move the body and to do work, to pick up large loads and so on. Hematopoiesis, remember hemato, that's about the blood. Poiesis, hopefully you're remembering production for poiesis, that's blood cell formation. And so we're talking about red blood cells, white blood cells, and these, they're not really cells, they're actually fragments of cells that are called platelets that are important in clotting, are all produced by connective tissues that are found especially in the red bone marrow that's found inside spongy bone. So the skull bones, the ribs, the sternum, the scapulae, the hip bones, the vertebra, and the epiphyses of the femur and the humerus are all locations of significant amounts of red bone marrow. And here we're looking at the ball, so they've broken the ball from the femur. So here it is, and they've taken a slice through it, so you can see the red bone marrow here. And then right at the very core, there's a marrow cavity that is filled with yellow marrow. So that's what it looks like in real life, the spongy bone with its red marrow and the yellow marrow that's found in the medullary cavity of the bone. Storage, and here are some more pictures of the adipose tissue, the rich, fatty marrow that's found in the diaphysis of the bone. And then, of course, the bone itself is a big storehouse for minerals. 99% of the calcium in our body is found in the bones. It's important for muscle contraction, we mentioned that, for blood clotting, for nerve impulses, we've already mentioned that too, and for moving molecules across cell membranes, especially when we're doing that active transport exocytosis. And the bone is also the site of about 90% of the phosphorus in the body. And we require phosphorus in order to synthesize the nucleic acids, DNA, and RNA, and that energy molecule, ATP. All right, so there we have it. We have all the means by which we maintain homeostasis in our bones, looking first at dietary factors, vitamins, at hormone productions, and at the role that using our bones plays, and then a good review of the functions of the skeletal system. Okay, just one more video to go. So.